is Antonio Fortunato, and I am Deputy Head of Crew Operations for the European Astronaut Center in Cologne. The topic of this lesson is the International Space Station. As a vehicle, we will discuss its modules, its main capabilities, and to a lesser extent, its operations. Now, what is attached to Node 1? We mentioned that Node 1 is an interconnecting node. So one important module that is connected to Node 1 is the joint airlock. Now, this is an airlock, so it is a module that can be used and is used by astronauts to go out in extravehicular activities, and it is called joint airlock because in theory it can support extravehicular activities both with the extravehicular mobility unit, so the American spacesuit, and the Russian Orlan spacesuit. The joint airlock is made of two compartments. There is an equipment lock. It is what you see here in the picture. This is where the astronauts suit up and prepare for the EVA. This is also the location where they perform the so-called in-suit lightweight exercise, which is what allows them to purge nitrogen from their blood in preparation for the spacewalk. The spacesuit has a pure oxygen atmosphere, so astronauts in EVA have to undergo procedures that are similar to what is used for diving. Now, once the astronauts are ready, all the systems are checked out, and they are also physiologically ready to go out in a spacewalk, they move into the crew lock. The crew lock is a much smaller compartment. It can be separated from the equipment lock by closing a hatch, and once that hatch is closed, air can be pumped out of the crew lock back in the equipment lock till we have basically zero atmospheric pressure. Once we have zero atmospheric pressure, the astronaut can open the external hatch and go out in EVA. Now there is one important point to make here. I've just said spacesuits use pure oxygen, and this oxygen is hosted in high pressure oxygen tanks on the outside of the ISS. Traditionally, those tanks were refilled by the space shuttle, and the space shuttle was in fact the only vehicle able to refill those tanks, which meant that when the space shuttle fleet was grounded in 2011, the ISS program had a relatively big issue because, okay, the assembly of the ISS was complete. There wasn't any more big need for having so many EVAs, but still there was a necessity to perform EVAs for routine maintenance, and we still had to protect for the possibility of sending astronauts outside and performing fixes to systems that may broke. And we had a few cases in the recent past. I mentioned, for instance, the failure of the pump modules of the external thermal control system. So obviously, the last space shuttles topped up the high pressure oxygen tanks of the ISS, but in the meantime, a system had to be developed to allow refilling those tanks also now that the shuttle is no longer there. This system has been finally installed just a few months ago. It's called Norse, and basically allows to carry bottles of small bottles of high pressure oxygen in the cargo vehicles that we have available right now, and then those bottles can be attached to Norse and can be used to refill the high pressure oxygen tanks. The other important module that is connected to Node 1, actually exactly opposite to the joint airlock, is Node 3. Node 3, you can see here the module in the picture as it is hoisted out of the cargo bay of the space shuttle and installed on the ISS is a module built in Europe. It's one of the European contributions to the ISS program. And it is a very important module. First and foremost, it provides the astronauts with gym-like equipment. We have seen that in the service module there is the B-2. This is the Russian treadmill. In the Node 3 we have the T2 US treadmill, and you see here ESA astronaut Luca Parmitano using it during his last mission to space. Now, the treadmill allows for aerobic exercise, actually for impact exercise, which is, by the way, very important in the very last phase of every astronaut's mission, because high impact exercise is what allows bones not to demineralize too much and to be still in a good shape for an astronaut to safely and successfully return to the planet. Of course, aerobic exercise is not all that is needed. We also need the astronauts to perform anaerobic exercise. And remember, each and every astronaut has to exercise for 2.5 hours every single day for the entire 6 months of his or her stay on board the ISS. Now, performing anaerobic exercise in a microgravity environment is not trivial. In a zero-G environment, you can't really do weightlifting in a traditional way, but by using wisely vacuum, it is possible to simulate weightlifting. And this is what is provided by the advanced resistive exercise device, the equipment that you see here being used in the picture. Now, gym-like equipment is not the only thing that is provided in Node 3. Node 3 also has the US toilet. You see here the inside of the so-called WHC cabin, or water and hygiene compartment. The US toilet and toilet in general is important not just because it allows to manage the human waste, but it is also important because it is connected to the so-called regenerative life support system. After the retirement of the space shuttle, we will not be able to support a crew complement of 6 people if we weren't able to recycle the water that is being used on board. And if we weren't able, in other words, to take the condensate water from the air and the urine produced by the astronauts, purify it and turn it into drinking water. This is one important component for the ISS, and it is one component that must be developed if we want to have a sustainable exploration program that goes further in the solar system, to the moon and then to Mars. The regenerative ECLS, or regenerative life support system, of course, doesn't just deal with the purification of urine. It is also taking care of a number of vital functions like the production of oxygen. Oxygen can be produced by electrolysis of water and the removal of carbon dioxide. Also, as part of the life support system, we have a major constituent analyzer. This is really a piece of equipment that takes samples of air from all over the station and analyzes them for components. So this way we are able to measure, for instance, the concentration of carbon dioxide in the air, and we are also able to recognize whether there are trace contaminants that need to be taken care of, that need to be removed. Carbon dioxide, by the way, is one very big problem for any human spaceflight vehicle. The human body is able to tolerate relatively high levels of carbon dioxide, but cognitive functions degrade as the amount of carbon dioxide in the air increases. Different levels of CO2 have been considered as okay, as allowable in the ISS over the years. It was not unusual in past years to have partial pressures of 4.5 millimeters mercury, but what we have seen over the years is that those levels are far too high for long duration missions. So the attempt now is to keep carbon dioxide levels consistently below 3 millimeters mercury. But this is very difficult because there is a lot of air inside the ISS. 6 crew is a large complement, and we really have to use our CO2 scrubbing equipment to capacity to make sure that we can keep carbon dioxide levels to within an acceptable limit. Now, one point that's really important to make here is that, yes, we have a regenerative E-class on board the station, but this is pioneering technology. This is really something that we are testing in space in a large operational scale for the first time. And we are discovering things as we go. We are discovering that these systems require a lot of maintenance. We are discovering that there are things that work well and there are things that do not work so well. And this experience is key to develop systems that work effectively, that work efficiently during exploration missions. You see here in the picture NASA astronaut Team Copra performing repairs on the urine processing assembly. As we said, the UPA is a key component. If we cannot recycle urine, if we cannot turn urine into drinking water, we cannot sustainably have 6 astronauts on board. So the UPA is an important component. It breaks every now and then, and the astronauts really have to work hard to keep the system in a working condition and to also help the ground understand what are the issues that are affecting the system so that lessons learned can be gathered along the way. Now, the node 3 is an interconnecting node. It is larger than node 1 and it has a number of other modules attached. One such module is the permanent multipurpose module. This is yet another contribution of Europe to the ISS program. The PMM used to be a multi-purpose logistics module. During the assembly phase of the ISS, there was the need not just to bring new modules to space, but also to bring payload racks, equipment, provisions to the ISS. And the space shuttle is a very capable vehicle. It was a very capable vehicle. It would carry a lot of payload to low Earth orbit and to the ISS, but the cargo bay of the space shuttle is unpressurized. So if we want to easily be able to transfer equipment to the inside of the ISS, we needed to have this equipment stowed inside a module that would fly in the cargo bay and would be then installed to the ISS for loading and unloading. Those modules were the multipurpose logistic modules, and they served a very important function during the assembly phase of the station. Now, when the space shuttle fleet retired in 2011, it was realized that it would have been extremely helpful to have an additional stowage module on the ISS. So one of the MPLMs was flown to space and it was attached to the station and became what we know now as the PMM. The PMM is really a stowage close it. There is no active equipment working in there, so the astronauts can really put there all the stowage that doesn't need to be used so often. We can put in the PMM, as you can see here in the picture, spare spacesuits. And this is extremely important because, yes, the ISS is a very large vehicle. There's a very large habitable pressurized volume. But at the same time, there is also an awful lot going on. And before the PMM was installed, storage was a really critical problem because we had to keep equipment stowed in other modules. And in other modules, you also have systems, you have payloads that you don't necessarily want to block with the storage bags. So having the PMM was a really nice addition.